this is Kasturi Day, and today I am going to start with the carbon dioxide portion of the chapter Carbon and its compounds. So I was discussing in my last video what is the how to prepare carbon dioxide, then what is rather carbon dioxide, its occurrence, its combined, it's found in combined and as well as in the free state. And we discussed about the preparation of carbon dioxide. How is it prepared? By burning of carbon and its compounds, by heating metal carbonates and bicarbonates, by action of dilute acids on metallic carbonates and bicarbonates. And also we discussed the lab preparation, where I asked you three questions. One is why we used marble chips, that is calcium carbonate. Why did we use that? It was used because this marble is preferred, that is calcium carbonate is preferred to other metallic carbons, because it is preferred because this it is cheap and it is easily available. So calcium carbonate, as it is very cheap and it is easily available, that's why calcium carbonate is used, and not other carbonates are used. Other metal carbonates are not used because of this reason. Then why dilute hydrochloric acid is used and not any other acid, especially sulfuric acid. Dilute sulfuric acid is not used because dilute sulfuric acid will react with the calcium carbonate, forming an insoluble calcium sulfate. Okay, and that will form a layer on the marble chips and that will stop the reaction. So what will happen? That calcium carbonate will react with dilute sulfuric acid, forming an insoluble calcium sulfate layer on the marble chips, on the calcium carbonate chips, and that will stop the reaction. That's why that's why dilute sulfuric acid is not used, but dilute hydrochloric acid is used. Okay. And another question was why the carbon dioxide is collected over air, okay, and not over water. Why? Because carbon dioxide is soluble, fairly soluble in water, and that's why it will dissolve in water to form carbonic acid, but it is collected by upward displacement of air, and also it is heavier than air, so it can easily collect above the air. Okay, below the air. Okay, so this is the question answers of the three questions, and now I come back to the today's discussion. Okay, I'll continue with this carbon dioxide only. So the physical properties, I'll tell you today. The physical properties: it is colorless, odorless gas with a taste is a slightly faint acidic sour taste it has. Okay, but if the gas is impure, they can have an acidic smell. Okay, if it is impure, then it can have some acidic smell due to the presence of hydrogen chloride vapors. Okay, because this it can contain some hydrogen chloride vapors, and that's why it can give an acidic smell if it is impure. If it is pure, then there is no odor. Then under ordinary conditions, it is heavier than air. It is 1.5 times heavier. So vapor density of carbon dioxide is 22 and that of air is 14.4. It is fairly soluble in cold water, but under pressure it dissolves rapidly in water. Okay, it can be liquefied under pressure. When liquid carbon dioxide is cooled, it cools it can be cooled to minus 78 degrees centigrade. Under normal pressure, liquid carbon dioxide can be cooled to minus 78 degrees centigrade. Under pressure, it can be liquefied and it can be cooled to minus 78 degrees centigrade. At that temperature, it changes to solid white, snow white solid, that is known as dry ice. So it freezes, that is liquid carbon dioxide becomes solid carbon dioxide at minus 78 degrees centigrade. So its freezing point, liquid carbon dioxide freezing point is minus 78 degrees centigrade, and it changes to snow white solid, that is known as dry ice. Okay, and it can sublime and can change directly into gas carbon dioxide, and it has a cooling effect. Okay, it is a non-poisonous gas, but excess of it can cause suffocation, and it may also cause death due to the lack of oxygen. Okay, and then we come to the chemical properties. It is neither combustible nor is a supporter of combustion. Carbon dioxide is neither it burns nor it supports burning. Okay, but some metals like sodium, potassium, and magnesium continue to burn in the presence of carbon dioxide. It turns moist blue litmus paper red because it has an acidic nature, because when it dissolves in water it forms carbonic acid, which is acidic in nature, and it can change blue litmus paper. Acids can change blue litmus paper red. It dissolves in water to give carbonic acid, which is a very weak acid. Okay, so the reaction comes like this: CO2 plus H2O forms H2CO3. Then it reacts with alkalis to give salt and water. Sodium hydroxide and carbon dioxide gives us 2NaOH plus CO2 gives Na2CO3 and water, H2O. Then again, this potassium hydroxide, 2KOH, that is an alkali, it reacts with carbon dioxide to give K2CO3 and H2O. Then when excess of carbon dioxide is passed through alkalis, a soluble bicarbonate is formed. See, when it is passed, this Na2CO3 is formed when limited amount of carbon dioxide is passed through NaOH, that is an alkali. When carbon dioxide is passed through it, converts to Na2CO3, sodium carbonate. But when excess of carbon dioxide is passed, it changes to this Na2CO3 and H2O combines with carbon dioxide, the excess of carbon dioxide, to form a soluble bicarbonate, that is sodium hydrogen carbonate, Na2HCO3. In case of potassium carbonate, it changes to KHCO3. Okay, NaHCO3 and KHCO3. And when it is passed through calcium hydroxide, that is we called lime water. Calcium hydroxide is also an alkali, and it is called lime water. It turns the lime water milky due to the formation of insoluble calcium carbonate. And again, when excess of it is passed, excess of carbon dioxide is passed through, again it forms a soluble bicarbonate, that is calcium hydrogen carbonate. Okay, and it becomes colorless, it dissolves in it. Okay, then metals like magnesium burns in the presence of carbon dioxide to form magnesium oxide and carbon black. So the magnesium metal, it reduces the carbon dioxide to carbon, and it gets itself oxidized. It uses the oxygen of the carbon dioxide to form an oxide, and it leaves the carbon reduced to carbon black. Okay, this magnesium carbon dioxide, magnesium plus carbon dioxide in presence of heat, it gives us what? Magnesium oxide and carbon. 2Mg plus CO2 gives 2MgO plus C. Then it reacts with metallic oxides to metal carbonates. Okay, so metallic oxides, it it reacts with them to form metal carbonates like sodium Na2O combines with CO2 to form Na2CO3. Even MgO combines with CO2 to form MgCO3. Then when red hot coke, which is a non-metal, when it is passed through it, it produces carbon monoxide. Okay, when red hot coke, when carbon dioxide is passed through this red hot coke, then it forms carbon monoxide, which is highly poisonous gas. Okay, next is the test for carbon dioxide. One, I told you that it when it turns that blue litmus paper red, because pinkish red, that because it produces a weak acid when combined with water. And it is, as it is a non-supporter of burning, it extinguishes the burning candle or smolders matchsticks introduced in a jar of carbon dioxide. So this is also a test for carbon dioxide. And third test is the confirmation test. You can say that when it is passed through lime water, it turns the lime water milky. Okay, and when excess of it is passed through it, again the milkiness disappears and it forms a solution. Okay, colorless solution because of the formation of calcium hydrogen carbonate. Okay, which is soluble in water. Then we come to the uses of carbon dioxide. So it is used in the manufacture of aerated drinks like soda waters, common soft drinks, etc. We know that when we open the soft drinks, no, open the bottle of the soft drinks, the cap of the soft drinks bottle, then we can see bubbles coming out. Okay, effervescence coming out due to the presence of carbon dioxide in it under pressure. Then it is used as a coolant and a refrigerant in ships, preservation of food articles like fruits, vegetables, meats, etc., which will otherwise perish easily. Even the atmosphere of carbon dioxide protects grains from insect attacks. So, in the form of solid dry ice, it can also protect fruits and vegetables, and in the form of gas, that is carbon dioxide gas, also can protect the grains from insect attacks. Then in hospitals, a mixture of 5% of carbon dioxide and 95% of oxygen, that is we called carbogen, that mixture. 5% of carbon dioxide and 95% oxygen, that mixture is known as carbogen. That is used in hospitals for artificial respiration, which is given to the patients who are suffering from gas poisoning, pneumonia, drowning, etc. That is deficiency of oxygen, and the person is feeling uncomfortable to breathe. Okay. Then used in the manufacture of fertilizers like urea. It is prepared by heating carbon dioxide and ammonia at the temperature of 150 degrees centigrade and a high pressure. It is used to manufacture urea, fertilizers like urea. Then it is used also to the manufacture of certain chemicals like washing soda, Na2CO3, and baking soda, that is Na8CO3. Okay, so carbon dioxide is also used for making chemicals, and it's used in the baking industry to raise the dough. Okay, like baking powder, which is a mixture of baking soda and potassium hydrogen tartrate plus starch. So three things are there in baking powder. One is baking soda, potassium hydrogen tartrate, and starch is there to it is used in the baking industries to raise the dough, and is added to the dough to release carbon dioxide that forms the spaces in the dough, so that the gas as the gas rises, making it porous, and so the cakes are soft, light, and spongy. Okay, then it's used by the green plants to manufacture the food. We know that green plants, when photosynthesis is going on, that is the process of photosynthesis, they manufacture food. During that process, green plants uses the atmospheric carbon dioxide, or rather they use the carbon dioxide they use the atmospheric carbon dioxide to produce their food, that is glucose, the starch which they produce. Next is, it is heavier than air, it is a non-supporter of burning. Okay, and so it is used for fire extinguishers. Okay, fire extinguishers. What are fire extinguishers? They are devices in which carbon dioxide is produced in different forms to be used as an extinguishing agent. Okay, when carbon dioxide is produced in different forms so that they can extinguish fire. It may be soda acid fire extinguisher, it may be foam based fire extinguisher, or liquid carbon dioxide fire extinguisher. So I'll continue with this fire extinguisher in my next video. Please go through this. If you have any doubt, please write in the comment box. Share with your friends. Hope you are liking the videos. Okay, and if you are a new viewer to my channel, please do subscribe. And if you are liking the videos, press the like button. Okay, and thank you for watching, and have a good day.